Thanks for joining, everyone, and welcome to our first ever LinkedIn Live. My name is Nick Barillo, and I'm the Executive Director of the Center for Hydrogen Safety. For those of you that are not familiar with the Center, we're a global nonprofit dedicated to promoting hydrogen safety and best practices worldwide. CHS offers a variety of safety resources to support the use of hydrogen in the energy transition, as well as traditional industrial and commercial uses. Our global community currently includes 100 industry giants, government partners, academic collaborators, and strategic partners. Today's LinkedIn Live session will focus on hydrogen safely moving forward toward our next fuel source. We'd like this session to be as interactive as possible, so if you have any comments or questions, feel free to drop them in the comments section, and we'll get through as many as we can during the conversation. So now I'm really pleased to be joined today by Dave Edwards, who serves as the Director and Advocate for Hydrogen Energy at Air Liquide. Dave is responsible for establishing and maintaining internal and external partnerships with industry, academia, government entities to advance the technology and business opportunities in hydrogen energy. Dave has been with Air Liquide for more than 25 years. He has a PhD in engineering and has spent his career in energy-related fields, including nuclear reactor design, cryogenics, engineering, and hydrogen energy. Dave, thank you so much for joining us today. Can you give our audience a little more insight on your day-to-day role with Air Liquide and why hydrogen has been a focus throughout your career?
Yeah, first I'd like to just thank you, Nick, for hosting me, and thank you for the Center for Hydrogen Safety. I think, as everybody knows, the center has now been around for just a few years, and it represents, I think, one of the themes that we're going to talk about today, and that is the transition, not just of markets, but of technologies and transitions to global economies and transitions in things like safety areas. So I think that'll be at least one of our themes for today. My role within Air Liquide is really to be the external linkage between things like policies and other stakeholders or trade associations. We're in such early stages of developing markets that a lot of effort needs to be made in not just selling into markets, but also then developing those markets and also developing the policy and structures that enable those markets. And so for me within Air Liquide, this is a somewhat unique position because hydrogen represents a somewhat unique business for us. At least hydrogen energy represents a unique business for us. We've, of course, been in the hydrogen business for more than 50 years, but in most cases, we're thinking about large industrial applications, pipeline systems, refinery systems, ammonia systems, things along those lines. And now, same molecule, but an entirely new potential for market. And of course, as we've titled this, our next fuel source, fuel implies a transportation fuel in a lot of cases. And so entering into a transportation fuel market is something entirely new for Air Liquide, and requires us to think about those markets and those potential stakeholders very differently. So my role is to try to connect those dots and enable our existing businesses and any new developments in our business to engage in those markets.
Awesome. Thank you, Dave. And as a quick reminder, as we're getting going here, please feel free to share your questions. We'll put those questions on screen as they become available to help Dave see them and as well to let you know that we're getting to your questions. So Dave, as the world moves to a greener tomorrow, with many companies and governments setting net zero targets for 2050 or sooner, renewables and alternative fuels have gained momentum in recent years. Although hydrogen is the most abundant element in the universe, it is new as a sustainable fuel source. Here in the US, it's not considered an alternative fuel it wasn't considered until the Energy Policy Act of 1992. Why are we now seeing the emergence of hydrogen projects throughout the world?
So I think there's a number of reasons, and we'll probably, in addition to the theme of transitions, we'll see the theme of flexibility show up, that hydrogen isn't a single solution offering in that it's not just a transportation fuel. We see the potential for hydrogen in industrial sectors. In fact, as I mentioned earlier, we've been in the business for 50 years. Those businesses themselves have the potential to reduce their carbon footprints by adopting renewable and low carbon hydrogen to replace the fossil-based hydrogen they've used traditionally, for example. And then we can think about the potential displacement of natural gas with hydrogen. We can think of it as not just a transportation fuel, but a transportation fuel for those sectors that are extremely challenging, be it maritime or aviation sometime in the future is potentially. In most cases, we start thinking about single solutions that we want to bring to the table. We want to solve the light-duty vehicle market by shifting toward to electric vehicles and hydrogen fuel cell vehicles. We want to shift heavy-duty vehicles, trucks, for example, toward hydrogen-based fuels. Or we want to think about grid storage, for example, and using hydrogen from electrolysis while the sun and wind shines, and then to store that and use it to return power to the grid at other times. But hydrogen is flexible in that it can do all of these things. And that's one of the reasons that it's really getting some traction now, as we recognize that the energy transition is a very broad topic. It hits every possible sector. It may start in transportation, but it will end in all of the sectors as it becomes low carbon, as it becomes available, and as costs start to come down. That transition may take a decade or more, but we are in the early stages of doing it now, and it really is that flexible use that's driving the broad discussions. At the other end, though, it's also the flexible production. There are numerous ways to produce hydrogen. The feedstocks can either be from water, so take H2O and split it into hydrogen, or it can be from a hydrocarbon. That hydrocarbon can be fossil-based, that's how we would have done it traditionally, but it can also be from renewable hydrocarbons. It can be from biomass or from biogas, for example, and split the hydrogen off. Or in many cases, it's a combination of both water and hydrocarbons as the feedstocks. And so it's that multiple feedstocks leading to multiple usage that really is really the trick that hydrogen has. It's flexible in its sourcing, flexible in its usage, and therefore can adapt to whatever the local needs from an energy perspective are. And I think that's really the core of why hydrogen is getting traction today, as opposed to any single application space that really looks like the killer.
Thanks, Dave. Good perspective. We're getting a couple questions in these, and I'll jump back and forth. The first one here is relative to transportation and explosive nature of hydrogen as being some restraints to which are limiting its use. So maybe you could talk a little bit on that, and I can jump in as you're giving some perspective. So what are some of those things that are constraining its use right now?
So the biggest constraint for hydrogen is always its storage. In order to get the energy density sufficient to be a transportation fuel, you either need to store it at a gas at very high pressures, or you need to store it at a liquid at very low temperatures. And those two are challenging because in both cases it requires additional energy, and it requires essentially additional engineering and different technologies in order to be able to do that storage for the long term. If you look at today's light duty vehicles that are using hydrogen fuel cells, they're storing that hydrogen under many thousands of PSI pressure in vessels that are essentially carbon wrapped, next generation cutting edge storage technologies that are as light in weight as possible and yet can provide the high pressures necessary to get the energy density. So that becomes one of the critical factors, is how do you get enough hydrogen on board and how do you do it economically? The nature of hydrogen being very flammable and the explosive nature of hydrogen is one that we can address essentially through engineering controls, the design of those systems, the testing of those systems, and then implementing things like the regulatory requirements to safely use those fuels when we transfer them, when we store them, and when we consume them becomes sort of core to the issue. Regardless of what we're talking about with transportation fuels, we are talking about high energy density solutions, whether that's a battery, whether that's hydrogen, or whether it's our traditional gas and diesel. They have different risks and different safety conditions that need to be met. And different doesn't always mean better or worse, but needs to be addressed. And hydrogen is certainly among those. And as you could attest, Nick, the Center for Hydrogen Safety and its predecessors many years in advance doing the testing of components and the testing of protocols and procedures for safely handling hydrogen in a variety of transportation-related circumstances.
Yeah, it's a great point, Dave. I get asked the question a lot about hydrogen. I think there's a lot of background. People have different perspectives on hydrogen and its safety, and yet I think at times we don't consider that all the fuels we're using have hazards.
That's right.
You mentioned electricity and gasoline, absolutely, all have different hazards.
And what's new is always different, and what's different always is perceived as having new risks. Well, it does have new risks, different risks, but risks that can be addressed in some of the same ways. And as we've now got many decades of industrial operation with hydrogen under our belts, a lot of the learnings from that can also be applied to now these more commercial and fuel market opportunities. Although there absolutely are some new opportunities for learning and some new technologies being deployed and different challenges on where we face them. a hydrogen refueling station in a local neighborhood is very different than a hydrogen production facility in an industrial sector of what might be the same city. So the potential outcomes and the potential for incidences need to be addressed differently, and that's what these new market sectors bring, is the challenge of new and different implementations.
Yeah, here's another question relative to LNG. Can we benefit from our experience with LNG and hydrogen transportation? I think it's an easy answer to say yes, but let me get your perspectives on that.
Yeah, very clearly. So LNG and liquid hydrogen systems share a lot of things in common. They both operate at very low temperatures. They both have to be liquefied using cryogenic processes. Hydrogen a little bit more challenging because we have to go to much lower temperatures. Liquid hydrogen is on the order of 20 degrees Kelvin. Liquid LNG, I don't recall offhand what the temperature is, but much lower for liquid hydrogen. And so the things like the insulating systems need to be just that much better for hydrogen. The cryogenic systems that produce the liquid hydrogen need to be that much lower in temperature, for example. So it's very much we can learn off of them, but it's a level of refinement beyond. And by the way, the same equipment generally can't be used for the two. They either aren't compatible at the same temperature ranges, or in some cases, hydrogen and natural gas might have different interactions with materials, for example. So as part of the question is, can we simply use our LNG infrastructure? In general, no, but can we take our learnings from things like safety, from operations, from scale up, from market development? Absolutely.
Yeah, and I had seen a previous question here that was, is there no better fuel than hydrogen? And I think, I'm asked a lot about the whole concept of batteries versus hydrogen, and I think we need to avoid getting too caught up, because I think batteries certainly have a place and hydrogen has a place, and I think it's really important to consider that both are going to be important as we move forward towards electrification. Both have their uses, both have their benefits, and they'll be strong in some areas, and the other will be better in other areas. So what's your thoughts on that?
Yeah, there's a broad range of applications that need to go to zero emission in the transportation sector. And the needs for a light duty vehicle that you might drive and park in your driveway is entirely different than an ocean going vessel, is entirely different than a large truck that drives from city to city many thousands of miles potentially, or from potential aviation uses in the future. Each of those have very different requirements for what they're going to need and how they can solve them. Batteries will solve some of the problems, and whenever possible, we should use batteries. They're very efficient. In many cases, it's convenient to recharge them. A light duty vehicle, for example, if I have access in my garage to an electric charger, likely that 90% of my charging is going to happen there, and a battery electric vehicle probably solves most of my driving requirements. But if I drive a heavy duty truck and I need to go 800 miles and I need to go that with a 15-minute refuel, and I need to be able to do that in cold temperatures, and I need to be able to haul very large, very heavy trailers, for example, and uptime, dollars per mile delivered is my measure of success, it's very likely that fuel cells with hydrogen are going to be the winning vector there for many of those routes. And so when we think broadly about the entire challenges of the entire transportation sector, very clearly there's going to be room for both solutions. They are complementary rather than competitive in many, many cases. Even in the light duty space, what we see is that there are use profiles where fuel cells are absolutely going to be necessary, either because there isn't access to charging, or the operating scenario of the individual because of low temperatures or because of large miles or need for quick refueling are going to drive toward the fuel cell solutions as well.
Thank you, Dave. Here's another question on green or mostly green hydrogen. Is it economically feasible? And if not, what is the path forward?
So first, a little background on what we usually mean by green hydrogen. Most of the time when a question like this is asked, they mean electrolytic hydrogen, electrolytic from wind and solar or other renewable sources. That's usually how we characterize green. And I know we will probably get into it some more later, but there are a whole variety of different colors that get applied to characterizing hydrogen. Those characteristics are usually, what is the feedstock, what is its carbon intensity, and where does it fit into our energy portfolio? And so you'll hear about blue hydrogen and gray hydrogen, and then some other colors like turquoise and others as people bring them in. But back to green hydrogen. So if what we mean by this is renewable electrolytic hydrogen Is it economically feasible? So today it is more expensive than the lowest cost fossil-based hydrogen that's available, but we already see the trends in cost reducing dramatically. And those costs come from a couple of places. One is the electrolyzer, which is the equipment that converts the water or the electricity and water into hydrogen. The costs for those are going down dramatically as we move from what I would call boutique manufacturing facilities to large production line facilities making that equipment. We've seen equipment costs drop dramatically and can anticipate that maybe in a similar path to battery manufacturing, similar cost reductions for the future. And then the second part of the equation for the cost of electrolytic hydrogen comes from the cost of the electricity itself. As we introduce more and more renewables onto the grid, there is more and more time during the day when there is excess electricity being produced, and in many cases, very, very low cost. And so using that potentially curtailed power for electrolytic hydrogen has the potential to bring the cost of hydrogen or the cost of the feedstock energy down dramatically. That combined with favorable rates from large power producers, I think the future is very bright for green electrolytic hydrogen to reach at least a cost parity with today's fossil. And if you're familiar with the Department of Energy's 111 program, essentially to have $1 per kilogram in 1 decade, quite achievable at the production level. Although keep in mind that that $1 then has to be, that $1 kilogram needs to be moved to a practical use in a fuel tank. So distribution costs, liquefaction costs, things like that will make it so the at pump prices will be different. But the dollar per kilogram target is certainly at least a viable target for us.
Very good, thank you. Another question here for you. So relative to moving in that direction, how important will the policies be going forward to drive the hydrogen economy as net zero carbon becomes an imperative?
So the policies are critical today. The economics of hydrogen adoption as a transportation fuel cannot match gasoline and diesel today. If it could, we would already be making the shift at much more dramatic rates than we are. And so policy which encourages the adoption of these new technologies, policies which can bring down the cost of these new technologies, are ones that are necessary for this bridging period. So if we think about the various costs, there's the cost of the vehicles themselves. And so many states and even the federal government have incentives to either refund or rebate some of the price to reduce the cost of the vehicles themselves, for example. There's the cost of the fuel and things like the low carbon fuel standard and some of the other policies that some of the states have can actually address the pump price of the fuel, for example. And then there's the infrastructure, the stations and the other distribution networks that are necessary to bring that fuel into the markets. And a variety of different states and agencies are looking at how to make those kind of investments. And of course, the most recent infrastructure bill that passed last year at the federal level will help enable many of those investments into that infrastructure that's critical for that distribution. So in those three different areas, policy is certainly necessary in these early stages to adopt to a new energy transformation. And that would be true of any transportation fuel. We are an economy-based world, and in the U.S. Certainly we look at the price of fuels, which drives our adoption, and policies can influence those dramatically, and will continue probably for the next decade or so as we make this transition.
Yeah, and I think we see some of that happening. I've been on the Hydrogen Council's website, and they're showing that there's about $500 billion in projects in hydrogen scheduled for the next decade. So I guess we're seeing globally, that that many policies, many decisions are to invest, as well as I think maybe what's a little bit exciting that you see now is that some of the companies that have been traditionally hydrocarbon, some of your big oil companies, et cetera, are finding value in moving towards hydrogen. And I think that's really an exciting piece of what we're seeing as well.
Certainly, and the examples I gave were all based in the U.S., but of course, many countries around the world, a lot of the European countries, a lot of the Asian countries are making these same kind of policy implementations to make these transitions. Sometimes very much focused around the transportation sectors, but in many cases also focused on the large energy sectors for the grid and for natural gas displacement. And of course, the geopolitical situation in the Ukraine and others is making the need for natural gas displacement to become even more and more important as we think about the potential for hydrogen in some of those sectors. So at an international level, policies, while they may be different from country to country, they generally are addressing those same concerns. How do we get the right feedstocks and fuels down? How do we get the vehicles or the device that's going to use the hydrogen down in cost, and how do we manage the infrastructure in between? All of those are generally being addressed by different approaches in different countries, for example.
Thanks, Dave. I'm going to switch to a little bit of a safety-related question. Based on the data, I researched most of the hydrogen accidents are related to process management, human error, and maintenance. What do you think the reason for that is? So I'm going to get your opinion and I'll weigh in with mine.
Yes, Nick, probably you'll have better answers than I do, but my guess is if we replace the words in that question of hydrogen accidents to any accidents in general, that's probably a true statement. In almost all cases, when we look at industrial accidents and we do our root cause analysis, almost always there is a significant factor of process, human error, and things like maintenance or upkeep are typically part of that. And so I don't think it's unique to hydrogen. I think it's part of industrial and implementation, and especially around energy topics, that these become key issues. Nick, you might have some better specific references on if there are particular aspects of hydrogen that are particularly susceptible to this, but I don't think as a topic, hydrogen is particularly susceptible to human error any more than other energy topics would be, for example.
Yeah, no, you hit it right on, Dave. And I have a slide that I routinely show when talking about incidents, how the human error is anywhere from 60 to 90% of the incidents in those other industries. This could be just a large variety of industries from chemical to nuclear. Just those are typical numbers, and I think it just goes to show a problem that, as you stated, is not unique to hydrogen. All right, let me jump over to another one. Hydrogen has been lauded as our next leading alternative fuel source, from its ability to power fuel cells and zero emissions, to heating, to even to powering astronauts into space. Most importantly, it produces zero CO2 emissions when it's used in fuel cells. Why is it important for safety to be a focal point with nearly $500 billion of proposed hydrogen projects in play?
So from an industry perspective, we don't do anything without thinking about safety first. We recognize that safety is not just a requirement for a project, but it's an obligation for our employees, it's an obligation for our industry, and it's the foundation upon which we're based. You can look at that from a personal perspective, you can look at it from a professional perspective, you can look at it from a financial perspective. Almost any perspective you want to look at it, safety becomes a critical issue for any of these topics that we're thinking about. With hydrogen in particular, the challenge is back to that word we were talking about, transition. We're transitioning from 50 years of industrial usage to these new applications that are in new locations. The requirements for safety at an airport are different than the requirements for safety at a refinery, for example. The resources that might be available at a site at a refinery might be different than they would be at a bus depot, for example. And so having protocols in place, having training in place, and having things like monitoring in place that is specific to those new applications is really important as we think about these transitions to new locations. And so from our perspective, whenever we're looking at a new application, the very first questions we ask are, can it be done safely? Can it be done with the existing technologies that we already know how to use and already have proven? And can we get the right eyes on the project, the right expertise on the project? And can we get things like the local fire response team to be able to handle the circumstances that an accident might bring, for example? Those are always question zero before we even start thinking about what will the project be and how will we implement it. And to date, a lot of those are new and challenging because since we're new in the field, we're not repeating what we've done in the past and learning off of what we've done in the past specifically, but we're extrapolating from other projects and in some cases doing it the first time in the field.
Yeah, I get asked when I give presentations and meet with groups, I get asked frequently, what is the most significant safety hazard you see? And certainly there are technical issues that come into play and things with how hydrogen reacts and its properties and how it moves and flows. But the one area that we have found in the work that we've done over the past 15 years or so is that dealing with an audience that may lack the experience or expertise, communication of safe practices, of lessons learned and safe practices is really critical. And I think that's what the Center for Hygiene and Safety is really about. We're trying to help connect people with information, and I think that's the area that is the one that will play the most important role as we move forward. We've been involved in certainly back in the early 2000s. There was a fair amount of R&D activity relative to hydrogen, and I think we understand very well how the molecule reacts and performs, and that's, by the way, that's the same all over the world. It's not unique to North America or Australia or Japan or anywhere else. And so we have a good understanding of that, and how to do all that. But now we're really faced with users, stakeholders, a new group of folks that lack that experience and expertise, and really helping them to become familiar with those best practices, as well as become comfortable that it's another fuel, it's different, but it doesn't make it worse or better. It's just different. And so that's in my mind, that's a big part of the safety, especially as we move to training a workforce to be ready for this. What are your thoughts on all that?
In general, and maybe it goes back to that question that came up earlier, we're not technologically limited in our ability to do things safely. We have monitors, we have materials, we have storage vessels, we have ways to compress and move and liquefy that have all been proven to be safe. We're now using them in different ways. And so what is the challenge is that it really is the what's different. And what's different when we use hydrogen as a transportation fuel is essentially the user. And so the question earlier on why is it always something having to do with personnel and the people involved with training, it's because that is the new part of the equation in many cases. And having that right level of education, having the right level of respect for the projects you're working on and for how systems work, is really what's driving most of those differences. As you've pointed out, a lot of the times it's a matter of consistent messaging, and consistent messaging not just within a community, but across a nation and across the globe. Safety is one of the areas. We talked earlier about how policy doesn't always transition the same way from country to country or even state to state, but safety does. Safe procedures are things that we can standardize, are things that we can communicate, and things that we can make it the same everywhere. And when that's done, it really helps set a standard. Things like the fueling protocols for light duty vehicles that are now standard around the globe. Any vehicle could pull up, any hydrogen fueled light duty vehicle could pull up to any station in the world conceivably and would get fuel because the fueling protocol is identical. That's not the same for electric vehicles. It's not even the same for diesel and gasoline for that matter. But for the hydrogen vehicles, we've made that a single standard. And if you extrapolate that now to safe operations, you can make it so that the same communications, the same lessons learned, and the same safety standards can be met at a global level. And goes a long way to addressing some of the newness and the different parts that get associated with hydrogen introduction.
Thanks for that input, Dave. Here's another question. Is there any way to identify hydrogen leak like using mercaptan with LPG? And I'll jump in and certainly like to hear your feedback as well. I actually just got off a phone conversation with a group that is working on developing those odorants. There's some challenges with odorants for hydrogen. You have a very small molecule that can leak fairly easily, so keeping an odorant with that molecule can be a challenge. You also have the potential for contamination of fuel cells. So where we use mercaptans for natural gas, it doesn't quite work as well with fuel cells because it can contaminate and ruin those fuel cells. And then you have a very buoyant gas in hydrogen. So any type of odorant to stick with hydrogen might be a bit of a challenge, especially given that hydrogen is about 14 times lighter than air. So those are some challenges that we have ahead, but it really is interesting to see their organizations trying to tackle those challenges. Any other thoughts on that, Dave?
Yeah, I think with specific to odorants, the challenges of interacting in the fuel cell is really a challenge. But when I mentioned earlier that we're not technology limited in the things we can do, it doesn't mean we don't need new technology and technology developments. And being able to identify early on in very small leaks, because they can be precursors to problems in the future, is certainly one of those technology areas we're looking at. for all the technology regions you mentioned, it's challenging to use odorants, but there are other technologies in development as well. New types of sensors. There's color indicators that indicate a leak visibly rather than just simply relying on a detection of hydrogen itself, which can be challenging sometimes for the reasons you pointed out. So there's a number of things that are like that are in development, and those are the great opportunities for technology development, is to simplify some of the ways that we might do some of the safety indicators for issues. Odorants work fabulously well for natural gas, for propane, and for others, and it's part of our common knowledge. When we smell that, we know exactly what that is. There isn't a similar one developed for hydrogen, but wouldn't it be great if we had a similar way to identify an issue ahead of time?
Right. Okay, let me try this question. Are there any changes in approach to safety necessary to scale up hydrogen, especially around people with who are less specialists? And you know, I can jump in on this one. We recognize that there is a large group that's now entering with hydrogen as a fuel that may not have that experience, may not have that 100 years of experience that the industry does. And that's why, the center has put out some fundamental hydrogen safety courses and e-learning courses. There are webinars that we're putting on, and workshops and conferences. And the whole goal of this is really to help make a large amount of information readily available. And I think that's it. It really is the key, that we're going to have to walk this road together, and that we're going to have to utilize some of those resources. And we really have to give lots of opportunity for that fundamental information to be shared and to be consumed by the people that are involved in the activity. So even if we have a fueling station, for example, where it's at a convenience store on a corner, the people running that convenience store, really need some background understanding of what hydrogen is, and if they, what they might expect if there's a leak, and those sort of things. And so I think it's really important that we emphasize the need to share information, education, e-learning, webinars and courses. All that's going to be critical. Any other thoughts, Dave?
Yeah, I think it covers the entire spectrum. If you think about it from the consumer's perspective of the individual at the pump fueling their vehicles, we shouldn't need much in the way of training of that individual other than an awareness, because the vehicle itself is inherently safe and the fueling process is inherently safe. But then think about the person who maintains that vehicle. You take it into your local shop. Are they qualified to do high pressure hydrogen systems? Think about the person who's maintaining that fueling station or owning and operating that fueling station. Do they have the right understanding of the indicators of when there could be an issue and when there might be a safety hazard? And then think about all of the supply stream upstream, the construction of that facility, the delivery of those molecules, the production of those molecules. As you move further and further away from the consumer, it begins to look more and more like the things we've done industrially. But scale brings a big change. And what comes with scale is the need for more and more of the people qualified at those different intermediate points. If we introduce 1,000 vehicles into a market, we need a few stations that can do vehicle repairs. But if we have 1 million cars in a market, it means that probably every fueling station has to every maintenance shop needs to have familiarity with hydrogen enough to at least know what they can and can't do and where they can direct for appropriate service, for example. So scale brings that new level of awareness and that different type of and different numbers of skilled people in the workforce able to deal with hydrogen.
Very good. Okay, another question here. Issues on embrittlement, how can they be avoided?
So Nick will probably have better answers for this, but embrittlement really looks at two things. One is, have you done sufficient testing on that material representative of how the material is going to be used to know that it is or is not going to be a problem? And the second one is, if you're converting systems or if you're using systems where that's not known, can you do essentially an auditing process to understand what materials are being exposed and are they compatible? So in one case, it's, have you done your homework ahead of time on the material? And the second one is, for the specific application, do you know what materials are being exposed and what the potential risks are there? And as we think about things like, can we convert natural gas lines from natural gas to hydrogen? It's very much the latter question. The question I would ask is, do we have a good understanding of the materials in those pipelines sufficient for us to do an engineering study to say, yes, it's compatible, or no, it's not compatible for those conditions, and what would we have to change to make it compatible. If you're putting in a whole new system, well, maybe you can design materials and maybe you can select materials that are better suited for hydrogen applications and reduce that embrittlement. But it's at least in those two areas most of the attention of detail.
Yeah, and I think, in the certainly we have some great experts around the world that understand the embrittlement from hydrogen, and I sort of hear that consistent line coming from them, that the use is critical to the material's ability to perform well. So, for example, in many applications, stainless steel 316 is used for hydrogen piping, especially at higher pressures. I had one colleague that said to me, he said, "Well, silly putty could be used for transporting hydrogen if you had the right conditions." And so I think it really comes down to carbon-based materials. Some of those can tend to have problems, but if used at a very low pressure or a slight vacuum, those are not going to suffer much in the way of embrittlement. So your use condition is really critical to the embrittlement issue. Understanding, what materials you have, and the important part of embrittlement as well is understanding all the parts and pieces in that system. So it's not just the pipe itself, but it's the fittings and the gaskets in those fittings. And we've certainly seen a number of incidents that have occurred either as a result of an incompatible material in a relief device or an improperly sized relief device. And so those are all sort of things that embrittlement is not a showstopper by any means. We just need to be well aware of the conditions that we're using the hydrogen in and what materials work best in those conditions, as well as considering the best material relative to value proposition and risks and those sort of things. So absolutely. Let's go on to another question. What about ammonia? How about ammonia's role for the hydrogen economy? Do you see that coming into play? And this particular question wants to know for long haul vehicles. I'm not sure about liquid use of ammonia for that, but I also know in the transportation sector, trying to move hydrogen from one location to another, especially via maritime, ammonia has come up as a really good option. What are your thoughts?
It has, and if we broaden the subject a little bit to energy carriers broadly, ammonia is one of several that you might think of. So methanol is another option, and some of the liquid hydrogen, some of the carriers that react with hydrogen and allow you to hydrogenate and dehydrogenate at the site become options for you. As you think about moving hydrogen from one place to another, as we talked about earlier, storage is always a key issue. You either have to store it at high pressures or you have to store it at very low temperatures as a liquid. Those problems can be solved as we think about some of these alternative carriers. Ammonia, for example, can be stored at much lower pressures with much lower cost materials, but you have to convert the hydrogen into ammonia, then transport it, and then take that ammonia and break it down back into essentially nitrogen and hydrogen again. And the cost of doing that is really what factors into the decision as to whether you're going to use an intermediate carrier. And what you do if you're moving molecules from the Middle East to Houston might be very different than if you're moving it from Houston to Galveston. Because in one case, you might be moving many thousands of tons of hydrogen. In the other case, you might be only moving a few hundred kilograms of hydrogen. And the energy requirements and the equipment required to do that transition might very much define when and where you want to do that. The question here is for long-haul vehicles, implying that you potentially would use ammonia as the fuel on board and then use it in the form of hydrogen in the fuel cell. That would require onboard conversion of the ammonia into hydrogen. And while I know there are some developments in that technology area, I'm not aware of any of the current long-haul vehicle prototypes that are using ammonia on board as a fuel. Almost all of them are using either gaseous or liquid fuel on board, and then use liquid hydrogen fuel on board, and then using that directly in the fuel cell. I would think for the next few generations of transportation technologies, we are still going to see hydrogen, gaseous, and liquid onboard storage as the primary driver, and not that conversion of ammonia or other carriers on board. We might start to see that at some of the large transportation centers where you do need to move large quantities of hydrogen from one place to another. You are likely to see some of these intermediate carriers. We certainly will see ammonia projects. We already know of several that are in development. Very likely to see methanol projects, and it wouldn't be unexpected to see these other carriers show up from time to time as well.
So tying in with that, here's a question that asks, can hydrogen gas completely replace fossil fuels by 2030?
By 2030 is a very challenging day. 2030 is almost tomorrow. If we think about, just to give you some time frame, Air Liquide just opened a new production facility for hydrogen dedicated to the mobility markets in Las Vegas. That project, we started really in earnest about 4 years ago. It took about 2 years to get the design completed, the permits in place before we put the first shovel in the ground. It then took 2 years to put that shovel in the ground and turn it into an operating plant, which today is in its startup procedures and first coming online. So roughly 48 months, 4 years for a technology that is well known, for a technology that we've used for 50 years. The only difference is the market that it's going to, and the feedstock that we're using is renewable natural gas as opposed to fossil-based natural gas. In order to make the kind of transitions we would need to replace all of our fossil fuels in transportation by 2030, we would need to be doing that first off on almost a monthly basis, plants like that opening for the kind of scale we would need. But there would also need to be a lot of new technologies, a lot larger liquefiers, a lot larger distribution systems, a lot larger infrastructure. We would likely need pipelines to replace all of the fossil fuels by 2030. So the more realistic dates are longer than 2030. 2035 are the dates that states like California are targeting the elimination of ICE engine sales. But it doesn't mean that gasoline and diesel necessarily goes away on 2035. It means that new vehicles won't be introduced. So the transition will be longer than between now and 2030. But that said, there certainly are applications, certainly are customers, certainly are sectors where the conversion is happening today and will be complete by 2030. Some of those will be transportation sectors. The question generally asks broadly about fossil fuels, not just in the context of transportation fuels. And if we think about all the places that natural gas goes, for example, and all of the places that that fuel oils go, that's a very difficult challenge to replace all of that with hydrogen. What we envision is that hydrogen will play a role in displacing those fossil fuels. And eventually we as a society will eliminate fossil fuels. Hydrogen will be necessary to get there, but hydrogen is not the only step. It is just one of many technologies that will be needed. We'll focus on the transportation sectors. Hydrogen will be used in some of the very hard to convert sectors, but there's a lot of other technologies, especially related to electrification. When we think about wind and solar and other technologies there, they're going to help displace fossil fuels in the timeline of beyond 2030, between 2030 and 2050, for example.
Yeah, and you mentioned 48 months. I think maybe part of that is this, what we talked about a little bit earlier with people really coming up to speed with hydrogen. And so I think some of that delay is probably caused by it's a new fuel and people have to get comfortable with it and work their way through that. I would anticipate that as hydrogen becomes more available, as we see more installations and projects, that some of that time would come down as the comfort level rises. Would you see that as well?
I certainly would. I talked about 2 years of things like permitting. It was also engineering the plant during those 2 years. So it was more than just waiting on permits and a slow permitting process. Actually, 2 years is a pretty rapid permitting process for the size plant that we went through. So yes, all those things can be optimized. And if you think about transportation sectors, a lot of times it's the fueling station that is the critical point. If you think about California and the lack of stations limiting the number of cars that are there, permitting a lot of times is longer period of time than it is to put a station in place. Stations are in a lot of cases are skid mounted, dropped on the ground, and can be turned around relatively quickly, less than a year, to go from a flat site to an operating station. But the permitting, depending on the location and depending on the size of the station, can actually take longer than that. But you're right, as it becomes more and more ubiquitous, those permitting processes become more and more standardized, and the first time review becomes the nth time review, becomes much more manageable in those cases.
So I know for your company, Air Liquide has stated that hydrogen will not only help respond to the climate emergency, but also to the needs of populations and businesses. And further, Air Liquide wants to move forward hand in hand with the stakeholders, the hydrogen industry, without any blinkers, if you will, and without pragmatism. Why is in this process industry collaboration critical?
So I think there's a couple of elements to that. One is that the practical matters of an energy transformation are that it's a societal transformation. And we can't come in as an engineering company and simply solve engineering problems and move on. Everything that we impact, whether that's a local fueling station or a new fueling technology or a new fuel in the pump or a new production facility down the road, impacts society in a lot of different ways. And so we need to be moving forward with society outcomes in place to begin with. Things like reaching out to the disadvantaged communities that are disproportionately affected by the transportation sector. If we're going to decarbonize a port area, we need to take into consideration not just the needs of the port to move materials and to reduce carbon and to reduce energy costs, but also all of the people who live and work in that port area and how they're impacted by not just the carbon emissions, but really the particulate emissions, the noise, the truck traffic, all of the other aspects that go with that transformation, for example. And we need to be thinking about that from the beginning. That is more than the scope of what a company like Air Liquide can do. We require that engagement with the state. We require that engagement with the port, the customer, the operator, the local community, the environmental NGOs. Everybody's going to have a voice in these transformations, and if we're not working together on it, one will stall the other. And so going forward, that is the mantra of any of these projects, is that they need to be a collaborative effort between ourselves as the technology providers and the industrial side of things, but also with the societal side of who's being impacted and what voice do they have in the process, for example.
Very good. Here's a very specific question. What's your opinion of green hydrogen in steel industries?
So a very broad question. I can give a very broad answer. I think there's a huge future for renewable hydrogen in steel industry. Steel, as we know, is one of the largest carbon emitters on the planet, and there's lots of opportunities for hydrogen to displace the use of fossil, the use of coal, the use of coke, and many of the processes for the reduction processes in the steel industries. Steel industries are challenged, though, because an implementation of a new steel mill is a huge investment. It's difficult to do steel on a small scale. And so as we think about these conversions, it's very large projects that have to get implemented. One of the things that will be really powerful in the hydrogen hubs projects that the DOE is championing is that they will look at some of these very large industries and give the opportunity to do the first of a kind, second of a kind, and nth of a kind implementation into some of these very challenging industries at very large scales. Not just demonstrating the technology, but demonstrating that they can survive in the market using renewable feedstocks and compete in those steel markets.
Thanks on that. Relative to, here's another question. Precious metal catalysts in the fuel cells can be a large cost inhibitor. Do you see this as a barrier for the adoption of hydrogen as a fuel source?
You know, as we think about the technology impacts over the last few decades, if we go back to hydrogen production when fuel cells were first being developed, when electrolyzers were first being developed, there was a huge amount of focus on exactly this question. How do you bring those costs down by reducing the amount of precious metals in the catalyst and in the membranes and some of the other characteristics? There's been a lot of progress in reducing the amount of metals that are in those systems. If you were to have a guest speaker from Toyota, for example, or from one of the other fuel cell developers, they could give you specific numbers on the amount of reduction in these precious metals that are used in these processes, but it's been quite dramatic. And so the technology investments that we've made over the last 20 to 30 years now pays off as we think about a market development, a market transformation, because we've been able to reduce the costs and essentially reduce our reliance on the amount of these materials. There still are precious metals in those catalysts. Don't get me wrong, we're not down to zero, but we have greatly reduced that, and there's still opportunities for that to go further. So fortunate to have the decades of investment in technology specific to solve this problem and some related ones, leading us to a position now where we think we can succeed with the kind of numbers we have today in our systems.
Yeah, and I think I've seen some reports, recycling can get back about 97% of some of those materials.
So if the question was as simple as, will it be a barrier? I think the answer is no. Will it have to be incorporated as a mechanism for recovery, for recycling, for others? Absolutely. But I think we've reached a level where it's quite achievable.
Very good. So, so we mentioned the number of times about the U.S. with the hydrogen hubs and the $8 billion of funding for that, and also about the $500 billion worldwide. And then recently, BP is buying a 40.5% stake in massive renewable green projects. And when you look at this, in your opinion, is this just the tip of the iceberg?
It really is. In fact, it's such a big problem. Whether we look just at transportation fuels or whether you look at the potential for hydrogen in the energy sectors broadly, we're talking about terawatts of power, and we're talking about many billions of dollars of investment, trillions of dollars of investment. In order to do that, we need what are essentially these very large partnerships between companies, between countries, and between industries and the various sectors that they're engaging with. One of the really intriguing things about the hydrogen market, this new hydrogen market, is who the new stakeholders and partners are and will be. Traditionally, if you thought about hydrogen, there would be 3 or 4 companies, Air Liquide being one of those, that you might think of as the hydrogen providers. The hydrogen providers of the future could be just about anybody with an energy source. It could be your local power company might be producing the hydrogen. It might be what was a traditional fossil energy company, might have converted from petroleum sources to producing hydrogen, for example. It will be the traditional hydrogen companies like ourselves and others. It could be country states that are developing hydrogen overseas, for example. So who's in those markets and what role they play are really important. And the other thing is, what kind of industry partners are required for successful projects? In order for Air Liquide to be successful in the transportation market, we find that we need partners with people who drive vehicles. We're partnering with fleet operators, with bus management systems, with people that develop the vehicles, the OEMs themselves. Traditionally, these were not the kind of customers we worked with. But if you look at the kind of industrial partnerships that are coming out of these new hydrogen economies, it goes across just about every sector, and every possible company you can think of has a play in hydrogen and therefore has a potential for being a new partner. So at large scales, it's these big conglomerates that are getting together to solve the big problems because they're too big for one company. And at the small scale, it's these interconnectedness of all these different organizations that have a different foot in the hydrogen game, all coming together as partners.
Yeah, it's interesting. Somebody posted a comment, by the way, and it ties back to a colleague of mine said to me yesterday. Somebody said this will make a huge difference in our everyday life. And I think it's interesting to think how much that'll happen. I mean, whether it's, somebody traveling goods to your store, whether, so you're buying groceries off a shelf that have been transported by a fuel cell truck, to forklifts and an Amazon warehouse, so they're getting ready to ship your goods to you. All this is really going to be huge, and so thanks for that comment. Really great comment. I did want to impress before we run out of time that we've used hydrogen safely for more than a century. Certainly, Dave's organization has been a big part of that. A lot of good best practices, lessons learned. And so it can be used safely. It's important that we get the education, e-learning, all access to all those information resources to help us do that well. I think that the challenge for a new industry is that incidents can cause setbacks. We want to try and avoid that. Others mentioned human error here on the discussion as well. So any last thoughts about safety before we wrap this up, Dave?
I would just say the fact that we formed the Center for Hydrogen Safety in the last few years out of a conglomerate of other activities that were around safety is a reflection of this transition. We'll go back to the very beginning when I said transition was going to be a theme. It's been a transition for our safety functions as well. If you think about most of the safety activities that we were working on in hydrogen a decade ago, it was around understanding. What kind of research do we need to do to understand things like plumes or spills or leaks, and what are the effects of those? Now we're looking at things like how do we bring hydrogen into a fueling station, into a community? It's the engagement of safety, the implementation of safety, rather than that more fundamental understanding of safety. While we still need to continue to develop, to have better and better models, to have better and better systems for understanding the safety, it's that implementation phase, the transition to the implementation and implementation at scale that really is where the value of the center will come to play. Having a single location that we as industry can count on, that the world can count on, that we can use as a reference, as a resource, and as a consistent stakeholder in hydrogen safety, sort of represents that transition and represents the maturity of the markets as they develop. A fabulous step for all of us that you formed this center for on our behalf.
Thanks, Dave. So I want to remind everyone as we wrap up now, there will be a recording made available through the Center for Hydrogen Safety website. That's at www.aiche.org/CHS. Dave, I want to give you a chance to give your contact information in case anyone wants to reach out to you. Thank you so much. The insights, just phenomenal. We've worked together for many years, and I'm always impressed by how much you know and how much you're able to share your information in a very understandable manner. I really appreciate you being on for this inaugural LinkedIn Live for us. Great having you, and please share your contact information or whatever else you might like to share in wrapping up.
I will do that, and thanks so much for having me. I think this kicks off a really good discussion. Safety is so important to everything that we do, and all the things that we're doing in hydrogen. It becomes one of the core. Like I said, it's question zero in almost every project that we work on. If anybody has any follow-up questions, I can be reached very easily at david.edwards@airliquide.com. If you do a simple search on my name with hydrogen, inevitably you'll find the hit in there, or link back to the Air Liquide webpage, and you'll find my hits there. I really appreciate this opportunity. It's been a great conversation, and I look forward to continuing to support the center through Air Liquide and through our activities.
Thanks, Dave. And you can reach me, Nick Barillo, at nickb@aiche.org. I want to also encourage, if you've been on today or have listened to this recording and you find this valuable and you'd like us to do this, continue to do this, we'd love to hear your feedback. Also, if there's topics that you'd like us to cover, we're safety focused. This one will sort of kick everything off. But love to hear if you have some ideas on what you might want to talk about in the future. So thanks everyone for being a part of it. Love your questions. Great feedback as well. Look forward to being on another LinkedIn Live with you and discussing more topics. Have a great rest of the week.